We're going to be learning to understand inverse functions. So the first thing with inverse functions we need to think about is the notation, but also what it is. So the notation for a function is we've got f of x, and the notation for an inverse function is we've got f to the power of -1. You'll notice between these two, the x and the y values have switched around. So that's what we do for our inverse function. You'll also notice that we're going to be putting a line of y equals x. This is our reflection line. So we can see with the inverse, they are identical along this mirror line. So the same distance away. If we look at f of x, which gives us -1/3, if we flip that around, it will be 3 -1. Again, it's the same location on the other side of that mirror line. So an inverse function of what we've just done is the interchange of x and y coordinates. So if we think about it in terms of an equation, we've got f of x is equal to 2x plus 1. So f of x is normally referred to as y, so we just change them to x, and we change our x here to y. Now we just solve it, and we're going to get y by itself. So that means we're just taking 1 from both sides, and then we are dividing by 2. That gives us y equals half x, take away a half. So now we've got our inverse. And like I said before, the other way we can write inverse, instead of saying y here, I could do f to the power of -1 x is equal to half x take away a half. So we can see that on our graph here, because both of them have been graphed, we can see that we've got f of x here, and we've got f to the power of -1x, so the inverse. And we can see again, they're crossing here against the reflection line of y equals x, and it's the same distance apart. So one of the things we need to know about inverse, its function is it can only be a one-to-one function. But with an inverse, that is also a function. So it can be an inverse, be mindful of that, but it can't be a function if it's not one-to-one. And we'll explain that by looking at some pictures here. So if I look at a quadratic, which I will go to in the next slide, if I draw this, we know this is going to be y is equal to x squared. Actually, I'll make it basic y equals x squared, so I'll draw it at the origin. Now, if we straight away think about this, we know it's going to be a function y. It's a function because if I draw a vertical line, it only hits one spot, means it is a function. But whenever we think about the inverse, so the inverse of this is going to be y equals x, which changes it to x is equal to y squared, and we square root. So it'll be y is equal to the square root of x, and this is positive and negative. So if we have it as positive and negative, we're looking at both, which means it's going to the origin here again. I just missed it. It is on its side. So this time we can look at a vertical line test. And straight away, it's not a function because it's got two intercepts. So we know on the side here, it would have had to have been here, which is the horizontal line test for a one-to-one. Because it's not one-to-one, the inverse will not be a function. There will still be an inverse one. So this is what I was going to show you here. I'm going to grab these 2 points of f of x is equal to x squared. So I've got -2, 4 and 2, 4. We can see they are sharing 1 point. If I look at the inverse and flip them, so I'm going to have 4, -2, and 4, 2, we can see if I draw a line here, it's going to be crossing both of them. So it is not a function. So the reason why if it fails the horizontal line test, when you reflect the parabola in the line y equals x, you get a sideways parabola. So those are the two reasons. We can look at it here quite clearly, and I've used this in terms of Decima to make the clear graph. I can draw a vertical line test to show that it's clear that y equals x squared is a function. It's clear that the inverse is not a function. So let's look at this question. So we are going to consider the function of f with the domain of 0 to infinity for all real numbers. F of x is equal to x squared plus 2, fully define the inverse. Okay, so the first thing we need to do is we need to switch the x and y around. So f of x will turn into x and x will turn into. The next part we need to do is we need to rearrange to get y the subject. So I will be taking 2 to the other side. Then I'm going to be square rooting to get y by itself. We know with a square root, it will have a positive and it will have a negative sign. Now, as we saw before with a quadratic, we know that the domain of the function will turn into the range of our new function. So likewise, we know that our range of a function will turn into that of our. So if we think about the domain of a quadratic, we know that it's going to be all real numbers. Likewise, if we think about the range of our quadratic here, well, our range would be 2 or greater. So because of we're talking about 2 or greater, then that is what we're going to be putting here. Now, I just have to clarify one thing, and that is, even though I set the range as this, we've been given a range for our quadratic. So our range would actually be 0, affinity. Apologies, it's on a slight angle. So now the last part is we just need to write it in our function notation. So we know our function notation starts with f -1, colon, what is the domain of our inverse? Well, we know that will be the range. For all real numbers, f -1x is equal to x minus 2. Now, if we think about our range for this, our range is starting from 0 going to infinity, which also means that we need to be thinking about here on what we're going to have. So in this case here, it's going to be positive only. Let's look at the next question. So consider the quadratic function f(x) is equal to x plus 1 squared, defined on its maximal domain. From the rule for its inverse, so form the rule for its inverse and explain why the inverse is not a function. Well, the first thing we will do is we are going to think about this as a quadratic. So I will draw a picture up here. So I've got space. We know a quadratic, when turned on its side, is not going to be a function, because if we do a vertical line test, it's got 2 points. That means that because the quadratic function is not one-to-one, therefore it is a relation, but also it does not meet that horizontal test. without restrictions occurring. So we can make it a function if we put restriction on it. That links into the next part. If the domain of f is restricted to equal to b to infinity, find the minimum value of b so that the inverse exists. So again, I'll rub this out. I'll do it on the right-hand side. If I draw a graph, if I want to know where my quadratic is, so we always need to start it in the turning point. If I draw it in the turning point, it's going to be 1 to 1. Immediately when I draw the other half of it, that is where we have our issue. So the first thing we need to think about, one, what is the turning point? The turning point is, we can see, is going to be when x is -1, y is 0. That tells me the first. That gives me my domain for my function of going to be -1 to infinity, but it can be equal to -1. If I just sketch 3 points from there, and I'm sketching it just to be accurate, I can quite easily see that it is going to be a 1-to-1 function. Now, this is going to help us to be able to sketch our inverse. So if I wanted to sketch my inverse, I can just flip my numbers around. So that means instead of saying -1, 0, I've got 0, -1. Instead of me saying 0, 1, I've got 1, 0. And instead of me having 1, 4, I've got 4, 1. So using those 3 points, I've been able to draw my inverse of my function. And it's 1 to 1. Now, I'm just going to erase this. So now I'm just going to think about my domain and my range. So my range of my first function, we can see, is from 0 all the way up. So I can say range of f is 0 to infinity. That means this will now become my domain for my inverse. So we can see that is starting at 0 and going all the way. The next part I need to look at is what is my domain of my original function. My domain is from -1 to positive infinity, which means this will turn into my range of my inverse. So the next part that I've got is I've just drawn, I've just put on my function here. And so the next part, we need to make the equation. How do we make the equation? We change our y to x and our x to y. Now we've done that, we need to get y by itself. So we need to square root x. And we know square root will be plus and minus. And then we're going to get y by itself. So we're going to take one away. Now, if we connect this to what we have above, we can clearly see here a couple of things. One, with our range, we're starting at -1 and going to infinity. That means we're only looking at the up area, so we're only caring about the plus. So when I write it in function notation, I'm going that the inverse of f is I'm describing the domain 0 to infinity for all real numbers. The inverse, I forgot here to put x in brackets, is equal to square root x minus 1. Then we'll have a go at this question. It's find the rule for the inverse for f for real numbers except 1/3. Should be for all real numbers. Oops. I can start. Okay. Don't know what happened there. Okay. So it's going to be for all real numbers here. Oh, don't know what's happening at the moment. For all, for, for all real numbers, f of x is equal to 2x plus 3 over 3x minus 1. So the first thing I'm going to do is we're just going to swap x and y variables. So instead of saying f of x, I'm going to change this uh, to x and the x is to y. And the next step I'm going to do, I'm just going to re-go over and get y by itself. So I'm timesing everything by 3y minus 1. The next step would be expanding. So I'm just going to go 3y times x and 3x times negative 1. Now I've got everything here that I need. So I'm just going to grab, I want to get 2y over here. So I want all my y's to one side. So I took that over and I plus x to go onto my right hand side. After I've done that, I need to look at my two terms that I have with y and I'm grabbing my y out. So I'm factorizing. Now that I've factorized, I've got y in brackets 3x minus 2 is equal to x plus 3. The last step that we need to do is divide everything by 3x minus 2. That gives me y is equal to x plus 3 and 3x minus 2. Now we just need to be able to identify what is the range of f and what is the domain for my index. So just quickly, one way we can do that is we can change the form that this is in. So we already know the domain, which will be all real numbers except for 1/3 of our function. But if I wanted to change this form, I've just got divide. So that means I've set this up as 2x plus 3 divided by 3x. If I start with the first part, 2x divided by 3x is 2/3. 2/3 times 3x is 2x. 2/3 times negative 1 is negative 2/3. If I take them away, 3 take away negative 2/3, I'm left with 7/3. This 7/3 still needs to be divided by 3x minus 1. We can do this as keep, change, flip, and that means 3x minus 1 will sit nicely next to the 3 here. So this gives us our new rule of y equals 7/3, 3x minus 1 plus 2/3. I like this because it helps us see everything. So straight away we can see that one, we already knew we had an asymptote 1/3, but we also, this tells us straight away that we have got an asymptote at 2/3. This means if we're thinking about our range, and our domain. So our domain is stating here that we have got all real numbers except for 1/3. So this turns into our range. Our other asymptote, which we've got, is y is equal to 2/3. That was affecting our range. This is now going to affect our domain because they switch. So we know our domain will be all real numbers except for 2/3. So I can rewrite it as f negative 1 is described by all real numbers except 2/3. Our inverse function of x is equal to x plus 3 over 3x minus 2.